Good morning, and today we are going to talk about quadratic equations. This is the fourth unit of 10th class CBSE textbook, and there are about 4 exercises in this, and let's see what best can be done today. Quadratic equations. Okay, and the standard form of this quadratic equation is ax square plus bx plus c is equal to 0, and a, b and c, they belong to the set of real numbers, and a is not equal to 0. So ax square plus bx plus c is equal to 0 is an equation. Of course, when a is not equal to 0 precisely, we call it a quadratic equation. Okay, means it's a second degree equation. And see, in x, we say this is a quadratic equation in x, because where we are using x as the variable. Fine. When you have an equation, when you solve it, we get the value of x or values of x. Because this is a second degree equation, we necessarily have to have two values for x which satisfy this condition. And here like the values of x, of course, which satisfy this equation, we call them roots of the equation. Okay, so roots of the quadratic equation, roots of the equation, generally we take alpha and beta for that. Roots of the equation, alpha and beta. See, when do you say it is a root? See, in the equation, in place of x, if you substitute that alpha, it should hold good. Then you say that alpha is the root of the equation. So I'll do it. So in place of x, if I write alpha, this equation holds good. A times alpha square plus b times alpha plus c is equal to 0. Similarly, if beta is another root, in place of x, you also can substitute beta, and that equation should hold good. So it is something like a times beta square plus b times beta plus c is equal to 0. So generally, when you have a second degree equation, there can be two values. So here you solved the quadratic equation, so you can say roots of the equation. But remember, in the previous chapter, when you were talking about polynomials, we went on exactly the same way, but it was not an equation, it was a polynomial. When we had a polynomial, we were talking about the zeros of the polynomial. Okay, and similarly here, this is an equation which sounds the same, ax square plus bx plus c. It's a polynomial. Ax square plus bx plus c is equal to 0 is an equation. An equation has roots and a polynomial has zeros. So that subtle difference you have to understand. Say sometimes it so happens that if I have this one, say ax square plus bx plus c, this is the polynomial part. Okay, this is the polynomial part. This is not an equation because I am not writing is equal to 0. If this can be factorized, okay, say for example, if I get say x minus alpha and times x minus beta or something like that, and by equating, then what did we say? Zeros of the polynomial we calculated. Zeros are alpha and beta. Now let me take a quadratic equation. This is a polynomial, zeros I said, and I take ax square plus bx plus c is equal to 0, and I can say resolve this into x minus alpha times x minus beta or something like that, and I put a numeric factor for the convenience actually, because you got a like this is not a monic polynomial, this is not 1 there, that's why for my convenience I put some k, and here also I do that. Now tell me if this can be written like this, okay, and I have got now the roots of the equation. roots of the equation, and alpha and beta we write. Okay, so anyway, here we say zeros and there we say alpha and beta. So having done that, of course, now we go ahead to identify if the given equation can be a quadratic equation. There is no guarantee that all the time you get a quadratic equation, because if the x square terms get cancelled and there is no such term, of course, the coefficient of x square can be, it's 0, then it is not a second degree equation, it is not a quadratic equation. Sometimes it so happens that you start with x cube, okay, term. This is not a, it's not a second degree equation, then it's not a quadratic equation. So interestingly, he has given a few equations. He wanted you to check if they can make a quadratic equation or not. That's the first exercise we have got. Okay, he will give you an equation and simplify it and check if that can be a quadratic equation. He said x plus 1 whole square, okay, and x plus 1 whole square and is equal to 2 times x minus 3. The question is this a quadratic equation? And let me just expand this x plus 1 whole square. You get a plus b whole square. A square plus 2ab, 2 times x times 1 2x plus 1 square is 1 and is equal to 2 times x and 2 times minus 3. And I bring this 2x this side, there is also 2x here and that gets cancelled. I am left with only x square plus 1 and minus 6 comes this side and becomes plus 7 is equal to 0. So whether we get real roots or imaginary roots, we are not discussing now. The question is very simple. Is it a quadratic equation? So the answer is yes, because x term may not be there. Don't bother about that. But x square term is there. You got 1x square and therefore this is a quadratic equation. This is a quadratic equation and there is no problem for this. I'll take one more equation and we'll just check if it's a quadratic equation. I have here, okay, and my second problem, another bit I am taking here, x cube minus 4x square, x cube minus 4x square and minus x plus 1, and this equals x minus 2 whole cube, x minus 2 whole cube. So you need to expand it on the right side and bring all the terms to the left side. Just check, you should have only some x square term, no x cube term, and rest of it is okay, like whether x term or constant you may have or you may not have, of course. Okay, let me just check this one, how this can be simplified, because this is an equation. I write implies here x cube minus 4x square minus x plus 1 is equal to, this is like a minus b whole cube, okay, a cube minus 3a square b plus 3ab square and minus b cube. A cube is x cube minus 3 into x square into 2 minus 6x square plus, okay, 3 into x into 2 square, so that is 12x, and minus cube of this 2 is 8. So something you got here. What I can do now is this x cube and x cube I can take off. I bring minus 6x square this side and you have here a minus 4x square. Bring that 12x this side, there is a minus x here, minus x minus 12x. This is 1 and that minus 8 comes to this side to become plus 8. There is nothing left on the other side. Simplify it. You got 2x square and minus 13x plus 9 equals 0. And there is no objection to say that this is a quadratic equation. You got some x squares, okay, which is a non-zero one. 2x square means it's a non-zero times x square you got, and some x and some constant also you got. This is a quadratic equation, no doubt about it. Quadratic equation. Okay, absolutely no doubt about it, because it is the form of ax square plus bx plus c is equal to 0 with a condition that a is not equal to 0. Represent the following situations in the form of a quadratic equation. This is what you are given, okay, and there is a condition mentioned there, and you have to write a quadratic equation corresponding to that. He says the area of a rectangular plot is 528 square meters. The length of the plot is one more than twice its breadth. Okay, one more than twice its breadth, and we need to find out the length and breadth of the plot. Okay, and the question here is not necessary for you to determine what's the length and what's the breadth and all that. Its only thing is, can you write a quadratic equation? Okay, if this is the condition, of course. That's it, and let us try. Okay, so now I just clear this part. So you are given length in terms of breadth. Okay, I take this as my third question. So I have my breadth, let us say, is equal to x. This is not given to you, you just say, and length is given in terms of breadth. He says length is one more than twice its breadth. You take breadth, multiply it by 2, twice its breadth, and one more than that. Okay, if you assume that the breadth is x, you know what length is all about. But he says that the area is 528 meters square. I'm not writing say meter, and area is in square meters. So, but I know one thing, that area, whatever I am given, that it is 528 meters square, this is nothing but length times breadth is given to you, 528 meters square. Okay, length times breadth is the area of a rectangle. Now, this is a 2x plus 1 times x, breadth is x, and that should be 528. Okay, and now let us form the quadratic equation. X times 2x is 2x square, x times 1 is x. Bring this 528 this side, is equal to 0. So this is the quadratic equation of the given condition. Okay, and now if we need to find the length and breadth of the plot, okay, and if you solve this quadratic equation, we are going to get it. But right in this exercise, it's not necessary for you. He's just asking, represent the following situation in the form of a quadratic equation. Quadratic equation has come, so you can stop it. The next one is the product of two consecutive positive integers. Okay, positive integers are 1, 2, 3, 4 and so on. Okay, you have so many infinite of them, but he is asking you they should be consecutive. Okay, one next to the other. So if you have any positive integer x, the immediate positive integer is one more than that. Okay, so my next question is, whenever you are given two consecutive positive integers, two consecutive positive integers, so whenever you are given that the numbers are two consecutive positive integers, it is easy for you to assume them as x and x plus 1. But remember, sometimes if you are given two even positive integers, they differ by 2. You say one of them is x, the other one is x plus 2. Even if you are given two consecutive odd numbers, even then they differ by 2, because 1 and 3 are consecutive odd numbers, they differ by 2, 3 and 5 or 5 and 7. But here you are given only positive integers, there is nothing like even or odd, and therefore the two numbers can be x and x plus 1. But he is asking the product of, okay, two consecutive positive integers, you have to imagine, let them be x and x plus 1, x and x plus 1. He is telling that if you multiply them, Okay, the product of those two consecutive positive integers, 306. Okay, we're going to get a quadratic equation. Of course, you can say the x times x is x square, x times 1 is x. Bring this 306 this side. That's it. This is a quadratic equation. So you see, you can imagine, like, this is somewhere around 306. You should have two numbers, something like 15 times 16. Probably you may have 240. Move a little further. Okay, 19 times 20. 19 times 20 is 380. No, you come back again. So somewhere between, say, that 16 and 20, you may get two numbers. When you multiply them, they must be consecutive numbers, of course, successive numbers, okay, which are next to each other, like, So if you multiply them, so you must get 306. You can even guess that, of course, maybe 17 times 18 or something like that. My next question is a very simple one. Okay, Rohan's mother is 26 years older than him. Okay, and because this fellow was born when she was 26 years old. The product of their ages in years, 3 years from now, okay, will be 360. And this is what we have to work out, of course, and write a quadratic equation. Now here, I want to tell you some a general understanding of your age problems. Okay, I'll just take off the first two sums. Age problems, when you work out, this is my fifth problem. And we have two people, Rohan and his mother, Rohan and Rohan's mother. And it is given that Rohan's mother she's 26 years older than him. If you say x here, she's 26 years older, x plus 26 years, x years. This is a supposition, of course. You just have to suppose Rohan's present age is x and Rohan's mother's age is x plus 26. One thing you should remember all the time is the gap, whatever you have, 26 years, it will never change. Throughout the lives of both, the gap is 26 years, because that doesn't change. But what changes is how many times her age is to his age, that changes. Okay, and the question is about 3 years from now. That is what we have to talk about, like, So after 3 years, suppose x years and x plus, this is present age. They are present ages. Now 3 years from now, what happens? After 3 years, Rohan will be, say, x plus 3, and add 3 here also, of course, because she also grows older by 3 years, that is x plus 29 years. Okay, so whenever you are given a problem that after 3 years, you add 3 to both of them. Rohan becomes 3 years older, present is x, he will be x plus 3 after 3 years. Present, it's x plus 26. 3 years later, it is x plus 29. The question here is, if you multiply these two, you must get, say, the product must be 360. So my quadratic equation is x plus 3. I'm talking about the product of their ages. Product x plus 3 times x plus 29. This is going to be 360. That's it. Let us get the quadratic equation. X times x, x square, x times 29, and 3 times x, 3 times 29 is equal to 360. Now consolidate this. X square you have here, then 29 plus 3, 32x, and you have an 87 here. Bring that 360 this side, minus 360. And what is the difference? x square plus 32x, these two remain the same. 87 minus this one, of course, 360, maybe 283. Yeah, 10 minus 7 is 3. Okay, this will be a negative number, like smaller number minus larger number. 10 minus 7 is 3. This is 15. 15 minus 8 is, this is going to be 5. Okay, 10 minus 7, this is 5. 15 minus 8 is 7. And this is 2 now, of course, 273. Okay, so is equal to 0. I just repeat this one. You have Rohan and his mother, and their ages differ by 26. It's all the time 26, no matter when you are measuring it. Always his mother must be 26 years older than him, of course, okay, throughout the life. But there is something very significant if you observe how many times is her age to him, and that's going to change. Let us say when Rohan is celebrating his first birthday, she'll be 27. Okay, it's to say that she is 27 times. 27 times. Okay, so with what number you multiply Rohan's age to get his mother's age, it depends on when you are measuring. That's going to change. Say for example, your father is 30 years older than you. Okay, you were born when he was 30. And when you are 30, he will be 60. It's only double. Okay, when you were born, of course, if he is 30, by the time you are celebrating your first birthday, he is 31. 31 times. Okay, when you are celebrating your first birthday. But when you are 30 years old, he is only 60, just double. When you are 60, he is only 90. It's just 1.5 times, not even double. So, how many times you have his age to your age, that changes. But any time, any part of the life, he is 30 years older than you. Even when you are 45, he is 75, just add 30. When you are 50, he is 80. Okay, you just have to add 30. But the difference doesn't change. But how many times the child's age, you get father's age, that changes. Continuously it changes. Fine. So this is exercise of 1. Okay, first part of that, 4.1. And in the second exercise, and you have to find the roots of the quadratic equation by factorizing. Okay, when I say factorizing, you have to take the left hand side of the equation and you factorize it. You don't factorize equations, remember that. Okay, so by factorization means you take the left hand side polynomial, whatever you have, and you factorize it. If you can write that left hand side as x minus alpha times x minus beta and is equal to 0, that is the equation. So product of these two factors you are getting 0 is equal to, so one of them must be 0. So let us understand that and try to solve the problems of 4.2. Okay, so I just take off this. This is 4.1 and I do a few problems from 4.2. So generally when you have to factorize, what we do is that we split the middle term of the polynomial, whatever you have on the left side of the equation. And let me do one problem to make you understand that one. This is 4.2 and minus 3x and minus 10 equals 0. And here the coefficient of x square is 1 and here you have minus 10 and the product is minus 10. And the sum is this minus 3x. Sum is the coefficient of x minus 3. So here you need to guess two numbers in such a way that if you multiply you must get minus 10 and if you add them you must get minus 3. So it's a simple guess, small numbers, minus 5 and 2. Okay, so minus 5 and 2 when you multiply you get minus 10 and if you add these two you get minus 3. And therefore here the middle term, whatever you have, we separate that into two parts. Instead of minus 3, we write minus 5 and plus 2. So this is, like by splitting the middle term, that's what you mean by that. So I write here x square. In place of minus 3, I write this and this, minus 5x plus 2x, and of course minus 10 equals 0. So in the first two terms, you can take out x as a common factor from these two, and from these two, of course, you can have a constant 2, like x times x minus 5 plus 2 times x minus 5 equals 0. If you take out x minus 5 as a common factor again, you are left with this x and this plus 2 and equals 0, and therefore x value is either 5 or minus 2. These values of x, we call them roots. Therefore there are two roots, one is 5 and one is minus 2. To ascertain the fact that these are the roots, what you could rather do is that in place of x you can put 5. Check here, 5 square 25, minus 3 times 5 minus 15, 25 minus 15 10, 10 minus 10 equals 0. So it's okay. This is one root. Look at this second root actually, minus 2. Minus 2 whole square is plus 4. Minus 3 into minus 2 plus 6. 4 and 6 are 10. 10 minus 10 equals 0. So whether you plug in either 5 or minus 2, the equation holds good. And therefore, these are the roots of the equation. And I take another equation, which is perhaps the root 2x square plus 7x plus 5 root 2 equals 0. So you have here root 2x square plus 7x plus 5 root 2 equals 0. Now I take the product. What could be the product? Root 2 times 5 root 2. That should be the product. Root 2 times root 2 is 2. 2 times 5 is 10. And therefore here product must be, you can write root 2 times 5 root 2, and I need that as 10. And I want the sum to be 7. Straight away you can take, this is the sum. Now we need two numbers, okay, which, like when you multiply, they should give you 10, and add when you should get 7. Okay, so 5 and 2 is a simple guess. So I write here 5 and 2. In place of 7x, write these two. In place of 7, separate it out. 5x plus 2x. So I just copy down the same equation, root 2x square plus 5x plus 2x plus 5 root 2 equals 0. For those of you who just want to check whether this is right splitting up or not, 5x plus 2x is 7x. That's number one. Second thing is, what is the product of these two? 10x square. Okay, 5x multiplied by 2x, 10x square. Product of these two also is 10x square. It is something like product of the means and product of the extremes. Both will be same. Okay, then you can say, yeah, that splitting is done correctly. Like, so out of these two, x will come out. Out of these two, let us see what comes out. Out of these two, x comes out root 2x plus 5. Remember when you are doing this, one, the same parenthesis must come there. Parenthesis means like bracket. So now I want to write the same here because I'm expecting that to be root 2x plus 5. Then what should I write here? 2x, if you want root 2 times root 2. Root 2 times root 2, 2x. That's what you got here. Root 2 times 5. That's 5 root 2 here. And now this is a common factor, root 2x plus 5. So root 2x plus 5 taken out as a common factor. I am left with x and root 2 here. X plus root 2, 0. Factorization is done, of course. If this is 0, my x would be, okay, minus 5 by root 2. and if this is 0, my x will be minus root 2. Okay, and therefore these are the roots. This is one of the roots and this is the second root. So roots we got like that. And in the next question, okay, and find the two numbers whose sum is 27 and product is 182. Okay, this is a question given to you. I take this like this. Now sum of two numbers must be 27, and if you multiply them you must get 182. The same two numbers, if you multiply 182, so you should be able to find out the numbers. That is the question. Okay, so now because the sum is 27, if one of the numbers is x, the other number would be 27 minus x. Okay, let the numbers be. Because the sum is 27, I want to use this clue actually. Let the numbers be. Let the numbers be. One of them is x and the other one is 27 minus x. Taking this clue. And the second one, let us say, if you multiply these two, you must get 182. So x multiplied by 27 minus x should be 182. That's it. Quadratic equation is framed. So you just have to solve it to determine what x could be. But there are no conditions given here. Like, any two numbers they can be. X will have two answers. Let us say now x times 27, 27x. X times minus x square, 182. So I just put them in order. First I write minus x square, then I write plus 27x. I bring 182 this side, and that side there is nothing left. I can now change the signs throughout. It's multiplying by minus 1 throughout. Okay, changing the signs. Come on, this becomes plus x square. Looks better. Minus 27x plus 182 should be 0. Okay, if this is the equation which I have to solve by splitting the middle term, I want to break this minus 27 so that the product is 182. Okay, so let us now, I write 182 I can write this as 791 times 2. Doesn't help me because if I add these two or in a difference or anything, it's not going to give me this one. So this is 7 times 13 and 2. So I have some clue I got now. What is that clue? I can take 14 as one of them and 13 as n of them. 14 and 13 can add and make this minus 27. So I'll do one thing. 7 times 2, 14. And there is a 13 here. I take minus 14 and minus 13, and this is going to help me. This is only, making a guess. Sometimes you call it a trial and error method. Okay, it is something like throwing a stone. If it hits, it's okay. Otherwise, take another stone and throw it. Okay, as long as you don't reach the target, you just keep on trying, and possibly you will get it. But sometimes it's not possible to get it. Okay, it can be a futile exercise. Okay, fine, leave it. Now we got, so minus 27 can be written minus 14 and minus 13. So I just write like this, x square, come on, minus 14x, minus 13x, and there is plus 182 and equals 0. So in the first two terms, x is a common factor, x into x minus 14, and in the next two, minus 13 I will take out because I want x minus 14. I want the same x minus 14 here. So if x is going inside, minus 13 is left behind, that's here, like minus 13 times minus 14 is plus 182. Come on, x minus 14, x minus 13 equals 0. So x can be either 14 or 13. Okay, here you must be a bit careful. So if x value is 14, the other number is 27 minus 14, 13. If your x is 13, the other number is 27 minus 13, 14. Doesn't make much of a difference. But these are not the answers. Remember that. Okay. If 14 is your number, first number, that's what we were assuming, 14. And this will be 13. And if this is 13, this will be 14. So it can be 14-13 pair or 13-14 pair. And those are the numbers. The numbers are, it can be 14 first number and second one is 13, or first one is 13 and the second one is 14. Just check once. If you add them, you get 27, and if you multiply 14 times 13 is your 182. Okay, I have my next problem. Find two consecutive positive integers, sum of whose squares is 365. There are two positive integers and they are consecutive. And if you square them, both of them, and add them, and your answer is 365. So let us take the numbers like this. Okay, I'll take out my 1 and 2. When you are given consecutive numbers, they are next to each other, rather they are successive, you can say. And if one number is x, the next number is 1 more than that, x plus 1. Or if one number is x, the preceding number is x minus 1. So if you want two numbers, you can take x minus 1 and x, or you can take x and x plus 1. Doesn't make much of a difference. It's sensible, you can choose any of these pairs actually. But if you square each of them and add them, and the answer you must get is 365. So I write like this first. Let the numbers be. This is my fourth sum in order. Let the numbers be. If one number is x and the other number is x plus 1. Okay, these are two consecutive positive integers. X must be positive. Remember that. But he is telling you square the first one and you square the second one, add them, and sum of these two squares of these two numbers, and you should end up with 365. Okay, if I am right. So sum of the squares of two positive integers is 365. Determine x actually. But by any chance, if x is a negative, that value is inadmissible because he gave that x is a positive integer. That's it. Okay, this point must be kept in mind. He said very categorically that the number you are considering, of course, it's a positive integer. And therefore, let us see now x square. I expand x plus 1 whole square, x square plus 2x plus 1, a plus b whole square. I expanded, and 365. So 2x square and 2x, 1 minus 365, the 365 comes this side. So minus 364 equals 0. Okay, 1, and this 365 comes this side, minus 365. 1 minus 365 is minus 364. When I look at the equation, there is something that is interesting. All are even numbers. So I can cancel 2 throughout. I can take half of this one, x square. I can take half of this one, x. I can take half of this one, 182 equals 0. And now my question is to factorize this one. In that problem, we have learnt something interesting. 14 13 is 182. The same 182 you have here. So I can write in place of x because I know 14 13. 14x, this in place of this 1x, minus 13x, minus 182, 0. And I take out x as a common factor, x plus 14. And in these two, minus can be taken out because minus and minus. 13 ones and 13 14s. So 13 can be taken out as a common factor. This is what you are left with. Again, x plus 14 is a common factor. And x minus 13 is equal to 0. So x value can be minus 14, or if this is 0, x value is 13. As I told you, you must be very careful here. This can be the value of x because x is a positive integer. So this value is inadmissible. Means I can't admit it. I can't accept inadmissible root. And therefore, x must be 13. And what are the two numbers? If this is 13 and this must be 14. Remember, I am not bothered about this minus 14. If my first number is 13, the number next to it is 14. Okay, therefore, the numbers are 13 and 14. The numbers are 13 and 14. Don't get confused that it's minus 14, how I got 14. It has nothing to do with this. This root is completely ruled out. You got 13, that's it. If x is 13, the next number is 13 plus 1. That is how I got my 14, not from this, okay, minus 14. So then the next one is, you know, like the altitude of a right triangle is 7 centimeters less than its base. And if the hypotenuse is 13, and let us work out, of course, because it's a right angle triangle and we can use Pythagorean theorem. Okay, and I take out this problem. So in this problem, we have here, it is about a right angle triangle. He says that the altitude is 7 centimeters less than the base. Altitude is 7 centimeters less than the base, and he has given that the hypotenuse is 13, and you have to find out the other two sides, of course. Okay, so my question here is, this is the altitude which is less than the base, and hypotenuse is 13, and this is a right angle triangle ABC, right angled at B. And if this base, if you assume it to be x, altitude will be 7 less than that. So we write here, let the base be x centimeters, and altitude then is 7 centimeters less than that, x minus 7 centimeters. So you have base, you have altitude, you have BC, you have AB also. And hypotenuse is given as 13, and this is x, and this is x minus 7, okay, all in centimeters. If that is the condition, you can apply Pythagorean theorem, of course, the relation between the base, altitude and the hypotenuse, of course. X square, x minus 7 whole square is equal to 13 square. Expand x square, this x minus 7 whole square, x square minus 2 into x into 7, 14x, plus 7 7s 49 is equal to 13 13s 169. Now this is 2x square, just consolidation, minus 14x, and 49 minus 169 will be minus 120, and that will be 0. Now, as you find even numbers throughout, of course, you can take half of each of them, of course, divide throughout by 2, like, you know, half of this is x square, half of this is 7x, half of this is 60, 0, half of 0 is 0. So now this minus 60 you can write like 12 times minus 5 or minus 12 times 5. That suits me because the difference is minus 7, minus 12 plus 5. And that is minus 7. So in place of minus 7, I am splitting that and writing like this is equal to 0, and x times x minus 12 plus 5 times x minus 12 equals 0, and x minus 12 is common factor, and leaving behind x plus 5, 0, and x value is 12 or minus 5. But x is the side of a triangle, okay, it can be negative. So this is inadmissible. This is ruled out, this can be. And I got x value, that's it. Therefore, x is nothing but the base. Base is 12. The moment you know that base is 12, you can find out the altitude. It is 7 less than this. Altitude is 7 less than the base. Now, how do you do that? This is 12. This is 7 less. 12 minus, this is 12. 12 minus 7 is here, 5. So, base is 12 and altitude is 5. And that is your right angle triangle, of course. So, having done this exercise 4.2 almost, method of completion of square is there, okay, and that method let us follow. Means you have some deficiency and you just write there and later you can compensate, okay. That's the method of completion of squares. Let us take the exercise for that. 4.3. Roots of the following quadratic equations, if they exist, by the method of completing the square. Okay, this is the question, and let us understand how exactly this is done. So I do it first algebraically, and later, of course, let us see how it can be resolved. Okay, now I take a general quadratic equation, and I want to find the roots of that equation. The standard form of the quadratic equation, as we have learnt, is ax squared plus bx plus c. I start with that. Okay, so now I have first my equation ax square, okay, plus bx plus c, 0. This is the standard form of the quadratic equation. For my convenience, okay, I multiply throughout by 4a. I tell you the advantage a little later. Okay, I multiply throughout the equation by 4a. So I write here multiplying throughout, throughout, throughout by 4a. Just watch and let us see later, of course, how it's going to help us, like, because you have chosen arbitrarily this 4a. Start 4a into ax square, 4a square x square, 4a into bx, 4abx, 4a into c, 4ac is equal to 4a into 0, 0 only. We have multiplied throughout the equation by 4a. I got a distinct advantage of that. Let's see what. So this is a 2ax whole square. 2ax whole square. I got some perfect square there. And what do I have here? 2 times I have something. This is something like p square plus 2pq. I am expecting that. P square plus 2pq. So this 2ax I write here. What have I got? 2 times 2ax is 4ax. But that's not what I have. 4ax. There is another b, and that b I put here. So 2 times 2 is 4 a b x. 4abx I have. That's all I have got. And is equal to this 4ac, I send it to that side. I write minus 4ac. And this is taking a form. Okay, this is taking a form. But there is something incomplete. Okay, I have p square plus 2pq. We need plus q square, because then only you get p plus q whole square. It is not p square plus 2pq. You need q square. So I need b square here. Okay, because square of this one I need here. But I can't write here itself. I should write this side also I should write. Let me do that. That is what we mean by completing the squares. Completing the square. Completing the square form. Come on. I got 2ax plus 2ax whole square. 2 times 2ax times b. I need b square here. B whole square or b square. And I can't add on the left side. If I don't do that, it can be simple b square. Either this or this, both are same. Of course, minus 4ac. So the left hand side, whatever we have, it is in the shape of a perfect square. That is what we mean by method of completion of squares. Okay, this is a square. We completed like. So p square plus 2pq plus q square. So this is nothing but p plus q whole square. 2ax plus b whole square. And the other side I have b square minus 4ac. I need to find out square root on either side because ultimately I want to get my x. I don't want this square here. So I find the square root on both sides, and that will be 2ax plus b, because this square will go, is equal to this side I must find the square root, root over b square minus 4ac. But mind you, whenever you are finding the roots, because these are all numbers a, b and c, so you may write plus or minus, because the result square root can be positive or negative. Fine. This b I don't want. I want to send it to that side. In a process of getting my x, this term is unnecessary. It can go to that side. So 2ax is equal to, b is going that side, minus b plus or minus square root of b square minus 4ac. Now my last step. This is 2a times x. Okay, multiplication. This 2a will go to that side, becomes by, and therefore x is minus b plus or minus square root of b square minus 4ac, of course, by 2a. So x value means it's the root. Okay, how many roots you should have? Quadratic equation, 2 roots. But how do you get 2 roots here? When you take plus, it is 1 root. When you take minus, it is another root. There will be 2 options for you, and therefore we have solved the quadratic equation. I just tell you how it's done. You are given ax square plus bx plus c is equal to 0. That's the quadratic equation. We multiplied throughout by 4a, okay, to give it the form 4a square x square plus 4abx plus 4ac is equal to 0. And 4a square x square is the 2ax whole square. That is the key aspect there. That's why we multiplied by 4a throughout, 2ax whole square plus 2 into 2ax into, of course, we need something there, that is b, and is equal to minus 4ac. Okay, adding b square on either side, we get 2ax whole square plus 2 into 2ax into b plus b square is equal to b square minus 4ac. And on the left side, you have got 2ax plus b, complete square you have got. 2ax plus b whole square is equal to b square minus 4ac. Taking square roots on either side of that, 2ax plus b whole square is equal to b square minus 4ac. So 2ax plus b is equal to root over b square minus 4ac. When you write the root of some numbers there, of course, you put plus or minus invariably, because it can be positive root or negative root. And therefore 2ax is equal to minus b plus or minus square root of b square minus 4ac. Hence x is equal to minus b plus or minus square root of b square minus 4ac by 2a. And that's how you get the value of x. So when you're given the quadratic equation ax square plus bx plus c is equal to 0, you have got the value of x from that. And that's what we mean by solving the quadratic equation. Now I have something a little more interesting, of course. I separate the roots there. One is when you take positive, and the second one is when you take negative. And I do a bit of a manipulation there to find out what's the sum and what's the product of the roots there. Okay, so my next part will be, I take the roots. I have 2 roots I got, minus b, when I take plus, root over b square minus 4ac by 2a. This is one of the roots. And there is another root when I take minus here, minus b minus square root of b square minus 4ac by 2a. So I separated the roots. Instead of writing plus or minus, of course, I said plus b once and minus b once. Now what is that I should do? These are the roots. I can write now sum of the roots. Sum of the roots is equal to, I must add this and this, minus b plus b square minus 4ac and minus b minus that, because these are like fractions, the same denominator you got, by 2a. Common denominator is 2a. I have added this and this. I added the numerators because the denominator is same common. 2a I have written. Here if you watch carefully, this part will go. And minus b and minus b, minus 2b, and there is a 2a in the denominator. If 2 is taken off, you are left with this one. And this is the formula to determine the sum of the roots, minus b by a. And my next part is, I want to find the product of those 2 roots. product of the roots. How I should multiply? I'll just see that minus b plus or minus square root of b square minus 4ac by 2a should be multiplied with minus b minus square root of b square minus 4ac by 2a. Now, if you look at this multiplication, it's a strange multiplication. It's quite easy if you understand the logic, because this is something like p plus q, this is p minus q. Okay, there a plus b times a minus b, a square minus b square. Okay, so how I do this is square of the first one minus b square minus, because p plus q into p minus q is p square minus q square. The second part squared, root over b square minus 4ac squared by denominator is 2a times 2a, 4a square, because this is multiplication. Okay, not like LCM there and all. Fine. Now you tell me this one, minus b whole square is b square, and square root and square will go, and minus of whatever you have inside, you tell me, minus of b square minus b square minus of minus 4ac plus 4ac by denominator is 4a square. These will go, and your answer is 4ac by 4a square, and 4a and 4a will go, answer will be C on a. So when you are given the quadratic equation ax square plus bx plus c is equal to 0, the sum of the roots, you need not find out the roots, remember that, sum of the roots is minus b by a and product of the roots is c by a. Without solving the equation, you can tell them. So sum and products of the roots, sum and product of the roots can be written from the equation without solving the equation. Okay, roots we may not know, but we know sum of the roots. Roots we don't know, but we know the product of the roots. So that's the intention is all about. Okay, now we can start exercise 4.3. Okay, and he is giving specifically an instruction, method of completion of squares. That's what he has given. Okay, an important note there. 2x square minus 7x plus 3 is equal to 0. This is my first problem of 4.3. 2x square minus 7x plus 3, 0. Now, when you look at this problem, you write this as a square of something, method of completion of squares, and before that I got a small thing to do. I want to take x square, make it a monic polynomial. Okay, no coefficient, I prefer that. Divide throughout by 2, because this 2 should go. Half of this 7 on 2 x plus 3 on 2 is equal to 0. I tell you the convenience a little later, of course. So the first part, I have square of x. But no problem, square of x. I need here 2 into a into b. Okay, minus is there, I copied minus. 2 into a into b. A square minus 2ab. A square minus 2ab. This x I can take here as it is, because it's a. This is also a. So now, how can I get the product of these three as this one? Okay, now I want 7, x is there, x is there. 2 times what is 7 on 2? 7 on 4. I just tell you why. This 2, if it goes in this 4, 2 will come, and that is what 7 on 2 is here like. Otherwise, you do one thing. There is something here. You have taken 2 outside. Okay, take half of this one. 1 by 2 times 7 by 2. Say 7 by 4 will come. Whatever you have, take half, because you put already 2 here. 2 times 7 on 4 is 7 on 2. Okay, that's done. Is equal to this 3 by 2. I want to go to that side, of course, minus 3 by 2. Like we were doing A with ABC, exactly the same way. Fine, here a square minus 2ab. I need b square here to complete this square. So I have x square minus 2 times x times 7 on 4 plus 2ab, b square we want, 7 by 4 squared. I can't write only this side, I must write that side also. This 7 by 4 whole square is what? 49 by 16. I write this side. You have minus 3 by 2, remember that, don't forget. So this is what we have written extra to make this a complete square. That is what we mean by method of completing the square. So what is this? P square minus 2pq plus q square. P minus q whole square. X minus 7 on 4 whole square. Let us simplify this one. 16 and 2. LCM is 16. In this 16, this 16 goes one time 49. 49. In this 16, this 2 goes 8 times. In this 16, this 2 goes 8 times. 8 times 3, 24. And 49 minus 24 is 25 by 16. My next step is I take the square root this side, square root that side. But when I take the square root this side, I get plus or minus I should write. Come on. Square root this side means this square will go. X minus 7 on 4 is equal to square root of this one plus or minus 5 by 4. 5 5 is 25, 4 4 is this one. There are two answers now. If this is plus one answer, if this is minus another answer. X minus 7 by 4 is equal to 5 by 4. That is one answer. X minus 7 by 4 is equal to, there is another answer here, minus 5 by 4. Close it now. Minus 7 by 4 will go to that side. 7 on 4 plus 5 on 4 and 12 on 4, 3. This one. X is equals, this will go that side. 7 on 4 minus 7 by 4 will go to that side. Plus 7 by 4, already minus 5 by 4 is there. 7 by 4 minus 5 by 4 is 2 by 4. 2 by 4 is same as 1 by 2. So these are the roots. X is equal to 3 is one root. X is equal to half is another root. So we have found the roots of the equation. Okay, we have found the roots of the equation by completion of square. Okay, that is the method we are following. I take another problem. Okay, it is fourth bit, 2x square plus x plus 4. That is given to me, and let me work out, of course. 2x square plus x plus 4 is equal to 0. My problem now is 2x square plus x plus 4. 2x square plus x plus 4, 0. And I divide throughout by 2 because I don't want this 2 as the coefficient there. X square, half of x, half of this 4. 0. Okay, so now I want to make a perfect square with this term and with this term. If anything is required, I will do it later, like, okay. I have x square, x whole square, 2 into p into q, I have to write here now, and is equal to, this plus 2 I don't want there, can go as minus 2. Now tell me about what I have to put. This bracket will come here, x. Okay, if this is half, I have taken 2 outside. What is half of this half? Because 2 is written out, 1 on 4. So you can understand like this, 2 times this 1/4, that will be 1/2. Otherwise, because you have taken 2 out, write half of this one. Half of half is 1/4, 1 and 4. Now this is not a complete square. P square plus 2pq. I need q square here. Means 1 by 4 ka square I need here. Come on, x square. 2 times x times 1 and 4. I must write 1 and 4 square here. This I added is p square plus 2pq plus q square. But this I can't add just this side. That side also I must add. What is the square of 1 and 4? 1 and 16. Same thing is added this side also. But minus 2 is there. Now tell me, this is x plus 1 by 4 whole square is equal to 16 is the LCM. 16 times 16, 1. In this 16 goes 1 time 1 is 1. And 16 times this 2, 32. And the answer is minus 31 by 16. Something, like which we didn't expect actually. Like, why? Square of this is always positive. No matter what you have inside, when you square it, it must be positive. But you got negative. I can't find out the square root of this one in the real number set actually, and therefore I leave the problem here saying that the roots are complex. They are not real, complex, because whatever you have inside, positive or negative, when you square it, it must be positive. But unfortunately, the result is negative. And therefore, as a perfect square is a negative integer, as we got a perfect square as a negative number, roots are complex because we can't find out the root in the real number set. Roots are complex. We just leave it here. Roots are complex, and we don't want to determine what the roots are, of course, because our work is only with real numbers. And find the roots of the following equations. You are given x minus 1 by x is equal to 3. And let me solve it. X minus 1 by x is equal to 3, and the roots we have to find out. And there is no method mentioned here. We can follow in any method, like x minus 1 by x must be equal to 3. So I take x as the LCM of denominators here. X times x is x square. In this x goes 1 time 1 is 1, is equal to 3. And cross multiplication, x square minus 1 is equal to x into 3, 3x. And x square, bring this 3x this side, minus 3x, this is minus 1, is equal to 0. So having got the quadratic equation, I want to find the roots using the formula. Minus b plus r minus square root of b square minus 4ac by 2a. Straight away I will get. So x is equal to, this is a, this is b, this is c, minus b plus r minus square root of b square minus 3 ka square 9 minus 4 into a into c, 1 into minus 1 by 2 times a is 1, minus of minus 3 plus r minus square root of, here you must be a bit careful, this is 9, minus into minus is plus, this is 4, 9 plus 4, 13, so root over 13 by 2. I have got two roots, 3 plus root 13 by 2 and 3 minus root 13 by 2. These are not complex number. We'll go into the imaginary part. No, these are just irrational numbers. These are real numbers very much. But only thing is, because of this, the condition, the roots can't be resolved because you don't have perfect root 13. So those numbers are irrational numbers. That's it. And we have few more exercises to be done, and I just take up one problem here, and you have to find the roots of the following equations, but you are not given the quadratic equations in its form, standard form, but you have to reduce them, the given equation, you have to reduce them to the quadratic form, and then you have to start solving that and find the roots. And one such problem here is, and this is the textbook third problem. I take my today's first problem, and 1 by x plus 4 and minus 1 by x minus 7 is equal to 11 on 30, and he has ensured that x value is not equal to minus 4 and it is not equal to 7. Because if x assumes these values, this denominator becomes 0 and this denominator becomes 0. And therefore, it is taken care that the denominators won't become 0, and you have to solve this equation and find the roots of the equation. But understand one thing, this is not in the form of a quadratic equation as it appears to be. So let us start working. The LCM of denominators I can take, it is x plus 4 times x minus 7. And in this product, x plus 4 goes x minus 7 times. X minus 7 times this one, x minus 7. Okay, minus. In this product, this x minus 7 goes x plus 4 times. In this product, x minus 7 goes x plus 4 times. X plus 4 times 1, it is x plus 4. And is equal to, as we have seen, it is 11 on 30. If you simplify the numerator, okay, x minus 7 minus x and minus 4. And x minus x gets cancelled, minus 7 and minus 4 will be minus 11 by, you multiply these two, x times x, x square, minus 7x and plus 4x is minus 3x, and the product of these two will be minus 28, is equal to 11 on 30. Okay, the next step is a simple cross multiplication. Okay, and I can cancel even 11 here, that would be better. Minus 1 times and 1 time. So this times say 1, because I am cancelling minus 1 here, and 11 is cancelled 1 time. Come on, this times 1 means this denominator x square minus 3x minus 28 is equal to 30 times minus 1, minus 30, and x square minus 3x minus 30 will come to this side, plus 30, and minus 28 is plus 2 is equal to 0. And this 2 ones 2, you can write minus 3 as minus 2x and minus 1x. I am writing the factors directly, x minus 1 times x minus 2, 0. So x value is, okay, either 1 or 2. Okay, so we have solved the equation which is not given in the form of the standard quadratic equation. And we move to the fifth problem here. In a class test, the sum of Shefali's marks in mathematics and English is 30. Sum of her marks in math plus English, of course, is 30. Had she got 2 marks more in mathematics and 3 marks less in English, the product of their marks would have been 210. Okay, now the sum of her marks now is 30. That's what you should understand, of course. So my problem goes like this. Her math marks and English marks together you are given as 30. So if one of them is x, the other one will be 30 minus x. Okay, let her marks be. We'll take in order. Let her marks be x and 30 minus x. Okay, this is mathematics and this is English. Okay, because sum is 30. If one of them is x, the other one will be 30 minus x, because the total is only 30 she got. Now the question goes like this. Had she got 2 marks more in mathematics, okay, had she got 2 marks more in math, and 3 marks less in English, 3 less in English. Now let us find out her marks now, because 2 marks less than this x, of course, her marks would be, okay, this is continuation of that. Her marks would be 2 marks less than x, x minus 2, 2 marks more, so x plus 2 in mathematics, and 3 less than this one. Okay, the minus 3 from this one, like 27 minus 6. Total marks 30. If you think that math marks are X, English marks would be 30 minus X. Now there is a hypothetical consideration, but that did not happen, but just a consideration. Had she got 2 more, means this will become X plus 2. And had she got 3 marks less in English, because this minus 3, because I copied the minus X, because 30 minus 3 will be 27. The product would be 210, because that's the question. X plus 2 multiplied by 27 minus X, and the product would be 210. You have to solve this quadratic equation. Now shall we multiply them? I am doing the continuation here. X times minus X square, 2 times minus X minus 2X plus 27 times X, 27X, plus 27X minus 2X plus 27X minus 2X, and product of these two will be 54, and is equal to 210, 210. Now minus X square, 27 minus 2 is 25X, and plus 54 minus 210, we need to, this minus 210 is equal to 0. Let us change the signs throughout. Okay, this is plus 54. Let us change the signs throughout. This will be plus X square, and this will be minus 25X. As it is, you tell me the result. 54 we have, and 200 and minus 210. But if you change the signs, this will become positive and this becomes negative. 210 minus 54. 210 minus 54. It will be 156. And that will be plus 156 is equal to 0. 210. This becomes plus when you change the sign, then this becomes minus. 210 minus 54 is 156. If you look at the problem, you can easily guess that 156 is 12 13s. 12 and 13, they add up to this 25. So I write the factors directly. Anyway, I write one more step. Minus 13x minus 12x plus 156 equals 0. And x times x minus 13. Out of these two, 12 is a common factor, x minus 13. And x minus 13 times x minus 12 equals 0. X value is 12, 13. So it is easy for us to guess. If math marks are, say, 12, if math marks are 12, English marks will be 30 minus 12. So math and English, if math marks are 12, English marks will be 30 minus 12, that will be 18. Another way, if math marks are 13 and English marks will be 30 minus 13, 30 minus 13, that can be 17. And let us verify now. Had she got 2 marks more in maths, this becomes 14. This becomes 14. If she gets, 2 marks more here and 3 marks less here, that will become 15. English marks become 15. And 14 into 15, that will be 210. Another option. Had she got 2 marks more here, this will be 15. This will be 15. And 3 marks less here, this will be 14. And 15 times 14, that is again 210. So that is how you have to check, because the sum must be 30. Don't think that whatever answers you got, these are math and English marks. No, X is only math marks. Math marks can be 12 or 13. Doesn't make much of a difference. In both cases, the condition is satisfied. But how do you get English marks? If math marks are 13, English must be 18 because the total is only 30. Okay, that's how we consider it. And the next one, I do 7th problem. Okay, and let me clear this. Here, the difference of squares of two numbers is 180. Okay, there are two numbers and the difference of their squares is given as 180. The square of the smaller number is 8 times the larger number. Okay, the square of the smaller number is 8 times the larger number, and find the two numbers. There are two clues given. The difference of their squares is 180. This is not an easy one, of course. You must be very careful in assuming the numbers. Difference of the squares. Difference of squares of two numbers. But you don't have numbers. Squares of two numbers. The difference of squares of two numbers is 180. This is the first one. And the second one is important because we should start there. The square of the smaller number, square of smaller number, square of smaller number is 8 times the larger number, is 8 times the larger number. Okay, now how do I start for this problem is, I take larger number, I assume that, then I get 8 times the larger number. I can find out that easily, like, and my smaller number is square root of that because square of the smaller number is that. Okay, then I have two numbers and from there I proceed to plug in these like clues in the first hint that we are given. Let us start like this. Let the larger number be x. Let the larger number be x. Okay, and square of the smaller number is equal to 8 times x. Square of the smaller number is equal to 8 times the larger number. Okay, so what is the smaller number then? Square root of that. Therefore, the smaller number is equal to root over 8x. So now you have larger number which is supposed to be x and then smaller number is root over 8x. He is asking now the difference of the squares of two numbers is 180. Square of the larger number minus square of the smaller number. The difference must be 180. That's it. That's a very simple proposition. So this is the square of the larger number. Larger number is x. Square of the smaller number, root over 8x. And let us simplify this one. This is x square minus root and square will go 8x and is equal to 180. And now let us go like this one. X square minus 8x. Bring this 180 this side. Minus 180 is equal to 0. Now how do you write 180? Okay, minus 180 so that I get this as the sum of those factors. So it can be like minus 180 I am given. You see how I am making a guess actually. I can take say half of this into 2. So 90 multiplied by 2. So this difference, the sum of these two can be minus 8 because they should be still closer. Take half of this one and double this one. Half of this is 45, double this is 4. If you add these two, you get minus 41. No, I have to get only minus 8. I divide this by 3, and I multiply this by 3. Okay, 15 times 12 also is this one. Still doesn't work. Okay, I divide this by 3, I get 5. I can multiply this by 3, 36. Even now I am not getting, because 36 minus 5 is only 31. Can there be any clue like here? Say, can 30 and 6 also you can have minus 24, and let us take, come on, 10 and 18 you can have, and this is going to work for us. We should have guessed it long ago. Okay, so minus 10 and plus 18 is okay, but this will be minus 18 and plus 10 because it's minus 8. Come on, x square minus 18x plus 10x minus 180 is equal to 0. I take out this guessing part. Here you have x times x minus 18 plus 10 times x minus 18 is equal to 0, and x minus 18 times x plus 10 is equal to 0. Therefore, x is equal to 18 or minus 10. Because the numbers are positive numbers, x must be 18. What is x actually? The larger number. Okay, larger number we said x. I write here larger number is equal to, what is the value of x you got? 18. Okay, smaller number. Smaller number is, you look at this one, 8 times the larger number is the square of the smaller number. 8 times 18 you take, or root 8x. 8 times 18. 8 times 18, 144. Square root of that is 12. So these are the numbers. We don't take the second option because larger number here you are getting negative, which we don't want actually. Because a larger number negative we don't want, we have taken the positive one, 18. And 8 times the larger number is 8 18s. You can get 144, and smaller number is the square root of that. Root over 144, that is 12. Okay, and I do 1 or 2 more sums of this exercise, and let us do the 9th problem actually. 9th problem. 2 water taps together can fill a tank in 3 on 8 hours. 9 hours. Okay. 2 taps can fill the tank. If both of them are working, they can fill the tank in 3 by 8 hours. The tap of the larger diameter takes 10 hours. The tap of larger diameter takes 10 hours less than the smaller one to fill the tank separately. Okay, and because the larger pipe takes 10 hours less, this is the total time when both are open. When both the taps are open, together they can fill. Okay, this much time. And a larger pipe means a pipe of larger cross section takes 10 hours less. Takes 10 hours less than the smaller one. The smaller one. When the pipe has got larger cross section, generally more water comes in and it takes less time. Okay, that's what you have to understand. While filling the tank, the pipe which has got a larger cross section takes less time. Let us say now the one with the smaller cross section takes X hours to fill the tank. Okay, we start with that. Let the pipe smaller one, smaller cross section. Okay, let the pipe of smaller cross section take X hours to fill the tank. Okay, X hours it takes to fill the tank. Now automatically the pipe of larger cross section takes less time. How much less? 10 hours less. X minus 10 hours. Smaller cross section takes X hours and larger cross section takes X minus 10 hours. But now while doing problems of this kind, how we do them is, in 1 hour, what can this do? Means 1 by X of the tank. Okay, it takes X hours. Imagine for some time, to fill the tank, a pipe needs say 5 hours. Then what do you say? In 1 hour, what can it do? 1/5 of the tank can be done. 5 hours time it takes means 1/5 can be done. You can read a book say in 2 days time. Okay. Then what you can do on each day is one half of the book. Half you can do today, half you can do tomorrow. So if you need 2 days to complete reading, in 1 day you can read half. If that is 2, this is 1 by 2. That's it. Similarly, let us do this one. Okay, in 1 hour, I write smaller pipe can fill 1 by X part, because this is X, this is 1 by X. And in 1 hour, larger pipe can fill 1 by X minus 10th part of the tank. If both of them are working, part that is filled is equal to this plus this. Let us do that. In 1 hour, both can fill 1 by X plus 1 by X minus 10. This is what they can fill if both of them are working. Okay. But how much time it takes is, you should take the reciprocal of this one, because earlier I said 2 days and 1 by 2 in each day, something like that. So in 1 hour they can fill this part. I take X times X minus 10 as the LCM. In this product, this X goes X minus 10 times, that multiplied by 1, X minus 10 plus. In this product, X minus 10 goes X times 1X. So your answer is 2X minus 10 by X square minus 10X. This is what can be done in 1 hour. Now, how much time it takes? You just take the reciprocal of this one. In 1 hour, this can be done. How much time it takes to fill? This by this, you have to take the reciprocal. But that is given as 9/3 by 8. As simple as that. Come on, start. Take the reciprocal of this one. X square minus 10X by 2X minus 10 is equal to 9/3 by 8, which also can be written as 8 9s are 72 plus 3, 75 by 8. Cross multiplication. 8 times this, 75 times this one, 8 times this one, 8 times X square minus 10X, 75 times 2X minus 10. Come on, 8X square minus 8X, 80X, 8 tens 80X is equal to, this is 150X and minus 750. Come on, 8X square minus 80 minus 150, there will be minus 230X. This will come this side, plus 750 is equal to 0. We have to solve this quadratic equation. Okay, I just clear this part so that I can resolve this one. So, what is the quadratic equation we have there? And this can also go. The quadratic equation we got is 8x square minus 230x plus 750 is equal to 0. Let us cancel 2 throughout because all of them are even numbers. This is 4x square minus 115x and half of this, of course, 375 equals 0. Now you have to get this one. What is the product? 4 into 375 is the product. 4 times 375 is 1500, and I can easily see this one, of course. Okay, 100 times 15 if I write, because the sum is of course 115. 4 times x square minus 100x minus 15x plus 375 equals 0, and I can take out 4x as a common factor, leaving behind x minus 25 minus 15 times x minus 25 equals 0. So x minus 25 and 4x minus 15 is equal to 0. So you can get x very easily here. X is equal to 25, or you can say 15 by 4. Now if this is the time taken by, okay, x we said this is the time taken by the larger pipe, of course, okay, because that's what we assumed in this problem. Of course, x value 25 we got, and you can understand what this 25 is all about. Yeah, this problem is 2 water taps together can fill a tank in 9 3/8 hours. The tap of larger diameter takes a 10 hours less than the smaller one. It takes 10 hours less. So larger pipe takes 25 hours and smaller one takes 10 hours more, because this takes 10 hours less. Smaller pipe takes 10 more than that, 35 hours. Okay, that's what you should understand. And let us, like if you want to verify this one, the one with the larger cross section takes 25 hours, 10 hours less than this one. In 1 hour, what can this do? 1 and 25. Okay. In 1 hour, what can this do? 1 and 35. Now, in 1 hour, if both are open, what part of the tank can be filled? 1 and 25 plus 1 and 30. Simplify that. Whatever answer you get, take the reciprocal, that much time it's needed for both of them if they are working together. Okay, that's an easy proposition. And we have here, the next topic is about finding the nature of the roots. Okay, and sum of the roots, product of the roots, and nature of the roots. And let us understand this one. And the other day, we found the roots of the quadratic equation using a formula. And let us recall it once. Ax square plus bx plus c is equal to 0. A is not equal to 0. We found the value of x. We said there are 2 roots, minus b plus square root of b square minus 4ac by 2a. And there is another root, minus b minus square root of b square minus 4ac by 2a. So these are the 2 roots we said. But there is some part which is lying under the root. Okay. So b square minus 4ac, okay, is under the root. So we should be very cautious about the value of this one, because this part is coming under the root. If it is a perfect square, suppose root over something like 25, 36, 49, no problem, you have the square root. The answer will be a rational number. Okay, if it is a perfect square. And remember, this value is called discriminant. And this is also represented by delta. Is represented by delta. Okay, remember this one. Now, if delta is equal to 0. Let us see what is going to happen. This will be minus b plus root 0 means this is 0. Plus 0 means the whole thing is 0. Okay. And here also minus 0 because root over 0. Minus b by 2a here, minus b by 2a here, because this part and this part are 0 only. So if delta is equal to 0, you are going to get only one root. Means you can say roots are equal. Roots are equal. And definitely you have real roots because there is no root to trouble you. Both the roots must be, there is only one root. The root must be their real roots you are getting. Now let me take, say if this delta is positive, so root over a positive integer inside, okay, then you have two roots because plus something is different and minus something is different. So this root and this root, they differ. It is to say, for example, root over, see inside you have a positive integer 25. So this will be plus 5 and this will be minus 5. So there are two different roots actually. Okay, so I write here, you are likely to get two roots, but they are distinct. So you get two distinct roots, two separate roots, distinct roots. Of course, they are real. Because a root over a positive integer, no problem. Like it can be, it's a real number. Okay, they are real roots. But sometimes there can be a tricky situation. What happens if this delta is negative? Means under this root, if you have a negative number, root of a negative number, it's not on the number line. It's not on the real number line. So I have to imagine that. So I get a root in such a way, I get two roots. There is no problem. This and this are different. But the thing is, under the root, you have a negative number here. So this part will be imaginary and this part will be real. Okay, and therefore the roots you are going to get two roots, they are complex roots. There is a positive part, there is an there is a real part, there is an imaginary part. You have a combination of both, and therefore I write two roots you will get. Okay, distinct roots you will get, no problem. Two distinct roots. However, and the roots are complex because there is an imaginary part also there. So the roots are complex. And therefore, if you can find out the value of b square minus 4ac when you are given a quadratic equation, you can talk about the nature of the roots even if you haven't solved that. There is no need to solve. But remember that there is no need to solve. But however, you can make a comment on the nature of the roots without solving. That's the beauty of this understanding of the discriminant. Okay, and in some other chapter, okay, like when you study the matrices, there is another chapter. There is another word which stands very close to this one, and that is a determinant. In matrices, you get the term determinant, but in quadratic equations, the term is a discriminant. Okay, discriminant means what separates it. Okay, what makes it unique? What way it can tell about the nature? Because it's going to decide, discriminate in the equations, and it talks about the nature of the roots. Okay, fine. Let us take up a few problems, we will understand. When you are given a quadratic equation, if you can identify the values a, b and c, you can find out the nature of the roots without solving the quadratic equation. Okay, my first question is a very simple one. Find the nature of the roots. This is exercise 4.4. First question, 2x square minus 3x plus 5 equals 0. A is equal to 2, B is equal to minus 3, this is minus 3, this is C. C is equal to 5. Now, my intention is to find the value of delta. Means b square minus 4ac. B is minus 3 squared minus 4 times A times C. So this is 9, this is 40. As a result, I got something which is negative, a negative integer. And this is going to decide the nature of the roots. As we learnt that if delta is negative, there are two roots, there is no doubt about it, distinct roots. But make sure to identify that they are complex roots, because under the root you are getting a negative number, that's imaginary. There is some real part, there is some imaginary parts, therefore the numbers are complex in nature. So we say roots are distinct, there are two different roots you can get, but remember they are complex in nature. Okay, because any complex number you will study in higher classes has got two components, real part and imaginary part. Okay, and I go to the next one. Find the values of k in each of the following quadratic equations so that they have two equal roots. If you want two equal roots, delta must be 0. Okay, if delta is 0, you get two roots. Okay, but those two roots are equal, and therefore you can say there is only one root because both the roots are equal. Okay, they are not distinct. It's only one root we are talking about. So I take one problem. Find the value of k he is giving, 2x square minus plus kx plus 3 plus kx plus 3 is equal to 0. And he gives roots are equal. If roots are equal, delta must be 0. As simple as that. Come on, substitute. K square minus 4b square minus 4ac, 4 2 into 3 is equal to 0. And k square is equal to 4 times 2 is 8, 8 times 3 is 24. And your k must be root over 24. Root over 24 means 4 6 24. 4 can come out as 2. That's it. So in this question, he has given that roots are equal. Roots are equal means they are not distinct. Okay, so delta must be 0, and equate that delta to 0. From that, find the value of k. Next, the third one. Is it possible to design a rectangular mango grove whose length is twice its breadth and the area must be 800 meters? Okay, length is twice the breadth, area is 800, and if so, find the length and breadth. Is it possible to design, okay, such a mango grove? It's very simple question, and length is twice the breadth. Length is twice the breadth. So you can say L times B. Generally we write the dimensions like this: length times breadth. You just mention that. That's how, you should have seen that, 4 feet by 6 feet, they read it as by, they write into. So you should be very careful when you're writing. The size of the room is 12 feet by 10 feet. You read it as 12 by 10. But while writing, you put an into in between. That gives you the area. Okay. And you also must have seen 24 by 7. That's how you read it. But while writing, you write 24 into 7. But don't read it as into 7. Okay. You read it as 24 by 7. Exactly same way. Length, breadth is x and length is 2x. This is the condition. But the area must be 800. 2x square. 2x times x is 2x square. 800. X square must be 800 by 2, 400. And x is the square root of that, 400. And that's 20. And if this is 20, this must be 40. Therefore, length is equal to 40 meters and breadth is equal to 20 meters. You have designed in such a way, length is twice the breadth is 20, length is twice 40, but the area is of course 40 times 20, and that is 800. That's an easy one. Is it possible to design a rectangular park? Perimeter is 80, remember that, and area is 400. Perimeter is 80 and area is 400. Let us see if we can design. Okay, And this is a very easy question. Perimeter formula is 2 into L plus B, and that must be 80. Okay, and area must be 400. So I take the first one, 2 times L plus B is equal to 80, because this is perimeter, 80. And this is area, length into breadth. And come on, what is L plus B? 80 by 2, 40. And wherever I have B, I can write 40 minus L. And this I want to substitute in second equation. Come on, length I don't know, L. In place of B I can write 40 minus L, and that is 400. That's the second equation. I substituted the value of B, of course, in the second equation. Solve it now. Minus L square plus 40L. Bring this 400 this side, and that side there is nothing. And change the signs throughout. L square minus 40L plus 400 is equal to 0. Now you simply have to solve this quadratic equation, and that's it. And you get the value of L. How do you do this one? How can you resolve this one? Is it possible? He is asking. Minus 40L. And let us, can you try, of course, because how you are going to get the value of L? If you are getting the value of L, because I take out that problem to avoid confusion, and if you can get the value of L, you can say you can have a park with those dimensions where the perimeter is 80, and okay, and let us work out. This is 20 20s, and 20 and 20 add up to 40. So if I resolve, I get L minus 20 and L minus 20, 0, and L is equal to 20. And therefore, what is breadth then? 20 times 20 is 400. So L is equal to 20 and B also is equal to 20. Or you can say L plus B is 40. This is where we have written. And remember, we have got a very special rectangle where the length and breadth are equal. He said, is it possible to have a rectangular one? But my answer is yes for that, with a small condition. Length and breadth are equal. It can be a rectangle, but it is called a square. All the time you must be very careful about this. A square can be called a rectangle. It's a specific rectangle where length and breadth are equal. So there is one more way of saying this one. All squares are rectangles, but all rectangles are not squares. I repeat this point. Any square you are considering, there is nothing wrong in calling it a rectangle, because this is a special rectangle where length and breadth are equal. What's wrong in that? All the other properties hold good. But you can't take any rectangle and call it a square, because unless all the sides are equal, it can't become a square. There's a very big condition there for that. Okay, fine. So here I have got a rectangular field, no problem, but it is such a specific rectangle where length and breadth are equal. Thank you so much, and that's the lesson, quadratic equations.